Greetings to all the viewers. Now we are going to conduct the session based on the Meyer reaction. It is the organic named reaction, which is the part of organic named reaction. So we dealt with series of sessions based on organic named reactions, which are available at the channel World of Competitive Chemistry. In addition to that one, natural products, heterocyclic compounds, engineering chemistry, environmental chemistry, intermediate chemistry, graduation, post-graduation chemistry, and also research point of view, academics point of view, competitive examination per view, all are available at the channel World of Competitive Chemistry. So this is the concept we retrieved from the textbook authored by Dr. Kavita Kottireddy Kotar. So organic textbook of organic named reactions, right? So let me introduce the Meyer reaction. The Meyer reaction is the photochemical ring expansion reaction. It taken between the beta diketone and the alkene. These two compounds taken as the starting materials and proceeded with a 2+2 cycloaddition reaction under UV light irradiation. Being it is a kind of photochemical reaction, so that light irradiation is essential for the felicitation of the reaction. Here beta diketone treated with alkene, so that cyclobutane will be generated as an intermediate compound. Being a 4-member ring system is highly unstable, sterically hindered one. That's the reason why immediately proceeded with retro-aldol cleavage via cleavage process, and 1,5-diketone will be the ultimate product. In order to achieve this reaction, diketone taken in the enolic form for our convenience, and here the olefinic compound taken UV light irradiation, being it is a photochemical reaction, you can achieve again diketone only, but the distance far apart. Here 1,3-diketone transformed into 1,5-diketone compound. In order to understand the mechanism in a well manner, 1,3-diketone is tautomerized, so that enolic form will be taken into the consideration, and here the olefinic compound taken, both are participating in 2+2 cycloaddition process. Here you can achieve cyclobutane intermediate. Cyclobutane is sterically highly strained one. That's the reason why immediately go for the ring opening reaction in this manner, and here you can achieve 1,5-diketone as a final product. Here the reaction mechanism, photoexcitation taking place. First of all, beta diketone well treated with this light UV light condition, so that photoexcitation is the part of the reaction, initial part of the reaction. Later on, tautomerized compound will participate in the 2+2 cycloaddition diketone with the alkenic compound. This is the important step of this reaction. Retro-aldol cleavage taken. After getting this cyclobutane intermediate, retro-aldol condensation giving rise to what? 1,5-dicarbonyl compound as the final product. In order to understand the reaction mechanism, here is the enolic form of the starting material. 1,3-diketone was taken, tautomerized form it will be, and here is the olefinic double bond taken, and light irradiation is essential for this one. So whenever light irradiation taken place, first of all the compound is gone to excitation indicated with a star mark. Being light absorbed molecule is energetic one, that is indicated with the star mark over there in the square bracket. Later on, here it is the singlet excited state, so it is indicated with 1 star, so the singlet excited state it will be. So intersystem crossing taken within the compound, triplet excited state is transformation, right? In the presence of UV light, singlet excited compound will go for the triplet excited state. After getting this excitation, the molecule is more viable for 2+2 cycloaddition. In this manner, homolytic fission taking place between the molecules, and here you can notice the odd electrons. Odd electrons will participate in the ring closure reaction in this manner, and here is the retro-del solder cleavage process. Finally, 1,5-diketone will be the ultimate product. Entire series of steps are indicated for the detailed mechanism in order to understand the Meyer reaction. The well manner, 1,3-diketone finally transformed into 1,5-diketone compound. General scheme is provided. I'm taking the better example for this one. Here is the compound with 1, 2, 3, 4, 5 carbons in the skeleton, and here the second and Fourth positions are accompanied by the ketonic functionalities pentane 2,3 dione taken as alpha name for the compound, and it could be treated with the ethene. Whenever ethene is supposed to be added over the dimer reaction is the process carried in between, so that here the chain elongation taken, so that pentane is elongated to heptane 2,6 dione as the final compound. This is in accordance with the DeMayo reaction. 2+2 cycloaddition is the process taken. Cyclobutane intermediate initially originated, later on it will be opened, and this stretched molecule formation is possible. The same reaction will be proceeded with various examples. I am taking isoquinoline derivative over there. H nu conditions and Pyrex filter is added over there. Acetonitrile could be the solvent media at room temperature. 1.5 hour time duration taken for this reaction. So whenever this is the case, here you can notice enolic form, ketonic form of this carbonyl compound and enolic form of the carbonyl compound. These are the essential functionalities for our reaction. Whenever they are treated with the molecule, here the formation of the intermediate product. What could be the intermediate product? Intermediate product will be the cyclobutane. Cyclobutane intermediate will be generated. How it will be? Here the ketonic compound, here the enolic compound. This entirely works like a diketone, 1,3 diketone. Then where we are getting olefinic bond? This olefinic bond is participating in our 2+2 cycloaddition process. This is said to be internal DeMayo reaction. Within the same molecule, reaction is proceeded, so that ultimately you can notice the cyclobutane derivative. Cyclobutane highly sterically strained one. Immediately what will be the next step? This will go for the ring opening reaction, and ultimately there will be a ketonic functionality at the position 1, 2, 3, 4, 5. 1,5 position double bonds will be originated. Initially it is the open chain molecule with this. An alkylated side chain will be there, and here it is finally converted into fused triannular system like this. So this is the way DeMayo reaction accomplished in order to get the final product in this reaction. Here is the another example for this DeMayo reaction. I am taking cyclohexane. Cyclopentane, and here the ether linkage, here is the double bond, here is the ketonic functionality, here is the olefinic double bond. When this is the case, what will be the product? This is one of the ketone, this is the another enolic compound, this is the olefinic functionality. These three are the essentialities for the DeMayo reaction, so that they will participate in the ring closure reaction in such a manner, so that here cyclobutane intermediate is formed by 1,3 diketone and alkene. Definitely it will be the DeMayo reaction only. Here is the cyclobutane derivative generated, here is the ketone which already present. Later on what process taken? So ring opening reaction, ultimately you will get a diketone at 1,5 position. So up to this only they concluded cyclobutane derivatives only they got, but both the products are having representation of stereochemistry only, difference in the representation of stereochemistry, but ultimately the reaction proceeded for ring opening and the generation of 1,5 diketone in this manner. So that step to be added over there. So this is also the part of DeMayo reaction. Here is the simplest mechanism what we already gone through. The mechanism is repeated one more time. Whenever enolic form of diketone was irradiated with the UV light, it will go for the excitation process. Any molecule absorbing the light that will be excited in nature. First of all, singlet excited state is accomplished. Intersystem crossing giving rise to triplet excited state. Excited molecule is more viable for the interaction with this olefinic compound by 2+2 cycloaddition process through homolytic fission of the bond free radical intermediate formation. In this manner, free radicals are originated. Ultimately, there will be a ring closure. You can achieve the cyclobutane as the intermediate compound. Steric strain will proceed for the opening of the ring immediately, and the 1,5-diketone could be the final product due to this bond transitions like this. This is the way 1,5-diketone will be achieved. In order to understand the reaction in the well manner, I am taking the compound with the benzene ring side. Here they connected with the ketonic functionalities. Here is the styrene molecule added over there. Simply homologation taking place in between two diketone compounds. This double bond carbon atoms will be added. Wherever red color marks indicated, these two carbons corresponds to the styrene carbons only, and wherever phenyl is there, that remains the functionality, the side chain only. And here is the phenyl ring, here is the phenyl ring, here is the phenyl ring located. But only the thing we need to understand is the 1,3-diketone will go for the insertion of this olefinic double bond by a 2+2 cycloaddition, so that chain elongation taken place like this. Two carbons will be extended in this manner, and the same reaction is applied with the kind of benzene which is in contact with olefinic double bond, and here you can notice only one double bond over there. Electron withdrawing group is added upon this adjacent carbon atom. If this is the compound taken, there will be a De-Meyer reaction taking place in between, so that ultimately these two carbons are inserted in between this double bond O and the carbon containing electron withdrawing group, so that here you can notice the red color carbon atoms belongs to the olefinic double bond carbon atom. This is the way chain elongation taken by two carbon atoms. And this is the ultimate mechanism. We already discussed the mechanism of De-Meyer reaction twice in this same session. That's a reason why I need not to go for this De-Meyer reaction. Once again, mechanism is well known, as we already aware. So initially the molecule diketone will go for the singlet excitation, followed by triplet excitation, followed by 2+2 cycloaddition. Between that triplet excited 1,3-diketone with this olefinic double bond, and ultimately cyclobutane derivative and the ring opening gives rise to open chain molecule. Then what could be the key features of the reaction? UV light is very essential in order to carry the reaction in the well manner, being it is a photochemical reaction. Here always the ring expansion reaction taking place. Two carbons will be extra added, so that 1,5-dicarbonyl could be the ultimate product. Here it works well with the beta diketonic compound enones. If taken, the work of De-Meyer reaction is very successful. Ring expansion is the common feature of this one. Wherever ring expansion required in the organic synthesis, you can apply De-Meyer reaction, being it facilitate for the two carbon elongation. Even complex natural products are simply synthesized by De-Meyer reaction in the laboratory viable pathways. Synthesis of medium-sized ring systems like 6 to 8 rings are very simple by this De-Meyer reaction. By this we successfully accomplished the entire session. These kind of molecules are accomplished, or the symbol of natural product they are made by, being a De-Meyer reaction is also taking part of natural product synthesis. That's why this kind of natural product taken into the picture. And if you want to observe the simplest example for the De-Meyer reaction, I am taking diketone compound with the methyl side chains, cyclohexanone taken as the olefinic compound like this. This double bond is responsible for the reaction with this. Whenever these two are going with the De-Meyer reaction, ultimately there will be a formation of 1, 2, 3, 4, 5, 6, 7. 7-membered ring is possible. 6-membered ring is extended like this. 7-membered ring formation taking place. Cycloheptane 1,4-dione could be the final product over there. This is the way the final compound is achieved. In the perspective of CSIR net key points, photochemical reaction is UV light is very essential for this one. 1,5-dicarbonyl compound will be the ultimate product via cyclobutane intermediate by treating beta diketone with the alkenic compound. Natural product manufacturing is the ultimate application of De-Meyer reaction. It is comparable with the pattern of Bucci reaction, the photochemical condition. Oxytane intermediate may not be generated, rather they are producing cyclobutane intermediates. By this we successfully completed the entire session, and this recording will be available at World of Conceptual and Competitive Chemistry, which is conducted by Dr. Kavita Kottireddy Kota, and you can obtain the YouTube channel link over there. And I'm an academician, researcher, and author, reviewer as well. If you follow the channel regularly, if you observe the content regularly, if you share with your friends, so definitely you can achieve the success in your journey of chemistry. Thank you one and all. Wish you all the best.